This video is on the multivariate chain rule, and the first thing I'm going to do is I have here a function of two variables theta and phi, and these variables in turn depend on some other variables, and we're going to take the partial derivative of z with respect to s and also t, but first let's do s. So you can remember the formula for this, or you can draw the diagram, which I guess I have to admit is a little bit helpful. So if you draw the tree diagram that you've probably seen in your calc textbook, you can see that z depends on theta and it also depends on phi, and then theta depends on s and it also depends on t. And also phi depends on s and phi also depends on t. If we find the partial of z with respect to s, which is the first thing we're supposed to do, this is going to be equal to, and we can label each of these transitions here with an edge. So this is going to be dz d theta to get down here, and then we need to go from theta down to s, so the transition is from theta to s. Okay, so I'm going to do that here. So I owe a partial of z with respect to theta, and I need to multiply by a partial of theta with respect to s. Okay, but there's another way to get down to s. So this is one way to get down to s, but you could also go this way, and so you need to sum in that path. So this is the partial of z with respect to phi, and here I need the partial of phi with respect to s. And that puts me down in the right place, and those are all the s's. So after I finish copying this, I'll be ready to actually evaluate this based on what the function really is. So we put the partial of z with respect to phi, and the partial of phi with respect to s. Alright, and now let's actually figure out what these things are. So this is just a simple partial derivative when we do this. So what's the partial here where theta is the variable? It's just cosine theta times cosine phi. Okay, so that takes care of that part. And now we need to do this. So we come over here and look and see what theta is in terms of s and t. So it's going to be just t squared, right? Okay. So let's do plus. Now I need to take the derivative of z with respect to phi, and that gives me the sine theta is now just a constant, and this part becomes minus sine phi, and now I've got the derivative of phi with respect to s, and that is 2st, and that part is now done. Okay, so there it is, and what we just did is this part. We still want to do this, really similar. In fact, there's no reason to compute these again. We can just copy them right over from the previous line. So dz dt is going to be equal to, well, what's going to change in this formula is that s is basically going to be replaced by t. So we still need a dz d theta. So here is that. So that is cosine theta cosine phi. But now I don't want to multiply by d theta ds. I want to multiply by d theta dt, which is 2st. Alright, so plus, or I should probably change it to minus, but now I'm just going to copy this line over. Sine theta negative sine phi, and now instead of taking d phi ds, I take d phi dt, which is s squared. Okay, and that's it. It's very easy. So there's the answer. I also have a couple slightly more abstract problems down here, just practicing using the tree diagram. So the general chain rule gives you the formal expression that describes how to take the derivative of a variable that depends on any number of variables, which in turn depend on any number of variables. But knowing what it means amounts to really being able to draw the tree diagram. So let's just draw the tree diagram for what's going on here, and maybe write down the form of one of the derivatives. So you've got u depends on x and y, and x depends on r s, and t, and y also depends on r, s, and t. So let's just take one of these derivatives. So if we were to take, say, du, I guess this should be a curly d, du, let's say s, then I've got to get here, right? So what is that? That gives me a du dx. And then from x, I've got to get down to s, and that gives me a dx ds. Okay, so that's not the only way to get to s, though. You can also go this way. So if I do that, I get a du dy, and now I go here, and that gives me a dy ds, and that's it. And now we could do the same thing for r and t, but it's repetitive, right? I'm not going to do it. This is slightly, it's not always the case that the initial variable depends on two things and then they in turn depend on three things. Really, you could have n things here and m things here, and you should look at this expression for the general chain rule and try to figure out what it's saying about that. But it really amounts to the fact that you can draw this tree. So w depends on r, s, and t, and r depends on x and y, and s depends on x and y, and t depends on x and y. And now let's find, let's say, the partial of w with respect to x. So what is this going to be? Just do it branch by branch. So you need dw dr, and here you need a dr dx. Okay, plus all these two other ways to get down to x. So you need a dw ds and a ds dx and a dw, I'm trying to get down to this x now, dw dt and a dt dx. And that's it. That's all there is to it. So I'm going to stop the video now, and that is the chain rule.